In this demonstration, I'll show you how to plot a sine function containing an amplitude and phase shift. This is part 1 of 3. This is the first question. The first thing that you have to do when it comes to graphing a trigonometric function is to be able to locate your a, b, and c value. Your a value is always the first number that is connected to the trigonometric function, your leading coefficient. Your b value is the number that is connected to the variable. And your c value, which will help you determine your phase shift, is right here. So let's write out what we know. Our amplitude is equal to 3, and when you find your a value, you always want to take the absolute. So your amplitude is 3, so if that were -3, for example, your amplitude would still be 3. And your b value is significant because it helps you find the period. Now, since our equation is defined in degrees, we have to use this formula and not this one. So your period is equal to 360 degrees divided by your b value. And your b value being 2 gives us a period of 180 degrees. That will be significant when it comes to plotting. With our c value, we can find the phase shift, which will tell us how much we have to shift to the left, to the right. Now, to find your phase shift, you need to know both your b and your c value. So let's represent phase shift with ps, and our c value is -90. Now, be careful because the formula itself also has a negative. So that becomes +90. And your b value was 2. So your phase shift ends up becoming 40, or let's go step by step here. 90 divided by 2 is equal to 45 degrees. So every point that you plot in the sine function will be shifted to the right because it's a positive number. So the next thing that you want to do before it comes to graphing, and you have to do these 3 things before you graph. But one other thing that you have to do is you want to find out your key points on the graph by dividing this number by 4. And if we divide this number by 4, we end up with 45 degrees. Now, that's also a significant feature. Let me show you how we can use this information to graph a sine function. So what I have here is a x and y plot where my x's represent my angles. We'll start off at 0 degrees, and we will use some point relative to the center as our amplitude. Well, we can be extremely accurate and say that this is 1, 2, 3, 4. And here we have -1, -2, -3, and -4. And what you have to do is you have to plot your period some point away from the origin. So we're going to represent this as our period. And what I've done here is I've split the period into 4 equal parts. So we have this part right here, this part, this part, this part. And that was the reason why I divided our period by 4. So I can find out what these represent roughly. So this would be 90. Let's see if I can erase that. 90 degrees. This would be 90 plus 45, which is 135. And here you would have a point at 180. So that's why it's very important to know what your b value is, because it helps you find your period, which subsequently helps you find these points. The next really important thing to do is to draw out the sine function. Now we know the sine function always starts at 0 and 0, then makes its way up to 1, then back down, just below, and once again above. So our sine function, squeezed in this small graph, without any sort of modification, would look like this. Now we have yet to apply 2 very important things. the amplitude, and the phase shift. So let's apply that. I'm going to use the color red. So this time, our graph will have an amplitude of 3. So that means it will rise up to 3 instead of 1, and then dip down, back to 0, and then back to -3, and up to the starting point. Now that is the sine function with an amplitude of 3 without a phase shift. We also discovered that the phase shift was positive 45, which means that every point will shift 45 degrees to the right because it is positive. So this point right here will shift 45 degrees. Now, to be fair and to be accurate, we have 1, 2, 3, 4, 5 box spanning every 45. So let's do the same. 1, 2, 3, 4, 5. So this point right here will shift right there. This point will shift 45 degrees this way. This point will shift 45 degrees this way. This will shift this way. And finally, this point will shift right there. And let's connect what's in green, but this time with a solid line. And what's depicted in green here is the function that we were supposed to draw. I will provide 2 more examples related to the sine function. The next video will be one where we deal with radians instead of degrees. And stay tuned. If you have any more questions related to this video in particular, use our website at biology-forums.com. See you soon.